Okay, so now I want to talk a little bit about paired data. So when each entry in one data set corresponds to one entry in a second data set, the sets are called paired data sets. One way to graph a paired data set is with a scatter plot. So a scatter plot, this is an example, is when you just plot each point individually for the data, and you don't connect them with any lines or line segments or anything like that. So you're just plotting individual points, and you're just kind of seeing if there's a shape or a pattern there. So a scatter plot is a graph where the ordered pairs are graphed as points in a coordinate plane, and it's used to show the relationship between two quantitative variables. So again, we're talking about quantitative data here. Sometimes, like here, I see a pretty clear pattern to me. So this looks like it's increasing overall. It looks linear, so it looks like it's almost forming a line, not a curve. It does look like I have two different clusters, so there does seem to be a bit of a gap here, which maybe I'd want to go back and do some more research on and figure out why, or get some more data points. But again, I can kind of graph those data points and get a general pattern pretty quickly and see if I see a relationship there. So this data is called the Fisher's Iris data set. It's about flowers. The data set describes various physical characteristics such as petal length and petal width for 3 species of iris, which are a kind of flower. And the scatter plot shown, the petal lengths form the first data set. So here are your petal lengths. And then the petal widths form the second data set. Now, it's kind of hard to see the exact value, so you can actually go back in your text on page 35 and see more about this data set. But just kind of, for instance, I'm just going to use this point here as you can see. So this looks like it's about at 50. So this is the point 50, comma, and then over here I have 10. So this says that the petal length is about 50 millimeters, and then this is the petal width. Is about 10 millimeters. So we're taking each individual point, looking at a flower's, let's say, petal length compared to their petal width, and we're plotting those points along our grid. So this kind of really goes back to those basics of the XY plane. Let's look at another point again, just to kind of review if you haven't seen, grids and points in a while. And again, I'm just estimating here because the point's a little bit hard to see on this graph. But let's say I do this point right here. It's kind of by itself. Again, I can line it up this way. It looks like it's about 30. And then maybe around 11. So it could be 11, 12, right? It's a little bit above 10. So to me, this is the point 30, comma, 11. So what I'm seeing here is I see the 30 represents the petal length. So this flower has a petal length of about 30 millimeters, and it has a petal width of about 11 millimeters. Okay, so each of these points in this case represents a different flower where we've charted their petal length with their petal width. And then we're looking to see if there's a pattern, and we do kind of see an overall pattern here, right? It looks like as the petal length increases, the petal width is also increasing, right? I'm kind of seeing this upward increasing direction here, which kind of shows that there is a relationship between these two variables. It's suggesting that as the petal length increases, so that petal length grows, the width is also increasing. Now, when we're graphing, so don't forget, you kind of have your XY plane here. Your x-axis is your horizontal, and your y-axis we've typically thought of as our vertical. Now in stats, we don't always use x's and y's. We tend to like to label. So you should be labeling all your graphs very well. And we don't always use x and y's because those may not be the best variables. So maybe I want to use L for length and W for width. It just depends on the information. But what you have here is you have your positives on the right. And then you have your positives also going up. Now you're going to see that most of the time in stats, we tend to focus on this first quadrant here because a lot of times our values are always positive. So what we're showing here is we're kind of getting rid of the rest of that 4-quadrant grid that we're used to because we're just focusing where our data is. Our data is here in the positive, so that's where we're going to go ahead and focus. You may have some examples that do have negatives. For instance, if I'm looking at temperature or wind chill or something like that, I could have negative values there, right? So if you do have negatives, then your negative values are below or to the left. Okay. Again, most of the time we're going to see that focus on this first quadrant here, but there are some cases where we may have negative values. So you could be using more than one quadrant for your scatter plot. And again, all of these are just plotted one at a time individually. If you need more help with graphing points or plotting points, just let me know and reach out and I can provide some more resources. Because we're just using that same techniques that we've learned, back in maybe 092 if you took it, or just, back in a beginning algebra course on how to graph. So using those same techniques of plotting our points on the x-axis or the horizontal axis first, and then the y-axis as well, and getting them to match up. So this is your scatter plot. Again, it's just the points. There's no lines or connections. We do have another similar style graph called a time series, which we are also plotting points, but we are connecting them with line segments instead. So a data set that's composed of quantitative entries taken at regular intervals over a period of time is called a time series. So the key here is that it's over a period of time. That could be seconds or days or months or years. It doesn't matter what kind of time, but over a period of time. And it should be at regular intervals, so not sporadic. Notice here that our data is for each year. So we have a data point for each year. It's very regular, a yearly interval. If we had data that was like 2005, then 2009, then 2011, and so on, we can still use it. So we do our best to be regular. We'd still use it, but it's not as good as having regular intervals. That's really what you want to see on your axis, particularly on your axes. If you're graphing, you absolutely need regular intervals. If you're looking at a chart, you could still use data that was not at a regular interval, but ideally, we should be taking calculations regularly so we can see the change over time. That's really what time series are about, is to see the change over time. So here, this example from your text lists the number of motor vehicle thefts in millions and burglaries in millions in the US for the years 2005 to 15. So these are your motor vehicle thefts, and these are your burglaries, excuse me. And these are in millions. So to find the actual number, you would take this and multiply it by 1 million, and then you can see exactly how many, motor vehicle thefts there were, for instance, that year. So what we can do here is create a time series graph, because we're looking at data over time, and we do have nice consistent intervals. So what we do is your time typically is always going to be your x-axis. There are some exceptions here, but in general, like 90% of the time, that time is always on your x-axis. So you see time here. And again, notice we're using consistent intervals, 1 year at a time. You do not want your tick marks to be bopping all around. They should go nice in order, just like a regular graph. You do notice that symbol here that's showing that we are cutting off some of our values for the years. This is fine on the x-axis. It's not an issue. It doesn't make sense for us to start at 0 if we don't have data to the year 2005, especially for counting by ones. It wouldn't make sense to have 2,000 tick marks that we're not using. So we use that little symbol. And then here we're looking at, this one's focusing on the thefts. So thefts in millions, and we're plotting each of those data points. So you can see this one here. So you see that lines up with 2005. So that's the point 2005, comma 1.24. So I have the exact data value here. So this is my X, for instance, and this is my Y in this case. And then you have the next one. So again, here's 2006. It lines up this way. And then going this way, it's 1.20. And again, I can check my graph with my raw data here. And this is a time series. So we can see that over time, it does appear that motor vehicle thefts are, sort of declining, maybe steadying out in recent years, but they have declined overall from 2005. But again, kind of a quicker decline and then more like a steady flat line there. Looks like it may be going up a little bit at the end. So this is your time series. Again, just a kind of another way that we can use a more traditional graph that we're used to, these line graphs, using little line segments here to see our change over time.